Supplement number 6. Felicia left Rome at 8 a.m. and drove her Ferrari at 80 miles per hour from Rome to Sorrento. Then she took the boat to Capri for the day, returning to Sorrento 5 hours later. On the return trip from Sorrento to Rome, she averaged 60 miles per hour and arrived in Rome at 8 p.m. How far is it from Rome to Sorrento? Okay, so the question is the distance. How far from Rome to Sorrento? Okay, our first step is to establish the location of our moving object. Okay, so let's draw the movement of our moving object. So, so Felicia left Rome. So, so we have our Rome. We can say that at this point, this is Rome. Okay, so she left at 8 a.m. 8 a.m. Going to Rome to Sorrento. Okay, so car, drive his Ferrari. Car at 80 miles per hour. 80 miles per hour. Okay, so that is he lives at Rome at 8 a.m. going to Sorrento using his car Ferrari with the rate of 80 miles per hour. Then she took the boat to Capri. She took a boat to Capri for the day. Okay, so in the morning, then returning to Sorrento 5 hours later. So if this is Sorrento, Miss Felicia have other agenda. She ride a boat going to Capri. Capri. It's island near Sorrento. Returning Sorrento 5 hours later. Then he go back to Sorrento 5 hours later. Okay? So this is the Sorrento. This is the same point. Okay. So on the return trip from Sorrento to Rome, she averaged 60 miles. So again, he used her car again. So the same object car but different speed. 60 mile per hour and arrive Rome at 8 a.m. 8 p.m. 8 p.m. So what is our observation? The distance from the origin going to Sorrento, going back to Rome does not change. So we can say that the distance from Rome to Sorrento is constant, D. Does not change. But if we analyze, she traveled 8 a.m. going to Sorrento, then 5 hours. He used 5 hours. Then later, after 5 hours, he returned back to going to Rome at average 60 miles per hour and arrived there at 8 p.m. So this is almost a 12 hours journey around the clock. So 12 hours journey. So that is already 12 hours. So if we deduct 5 hours at the Capri, so it's at the remaining 7 hours, right? Okay. So let's visualize and using our TRD. Let's gather up the data so we can construct our equation. Okay. So doing so, so instead of for example car 1, car 2, but he uses the same car. Maybe we can rename this to uh, going uh, going to Sorrento then back. So going muna tayo. We'll get the data from going then returning back. Okay, so then and we are tasked to determine how far is Rome from Sorrento. So this is our unknown, the total distance. So Felicia, okay, so what is our time? So here So our time here is unknown. We don't know the time, right? We don't know the time here. So we can let, okay, so we can let here, we can let x, we let x be our time in hours from Rome, to Sorrento. So we let the time, since we don't know the time, so that is x. So if we write our equation here, x, right? So how about our time going back? Okay, again, let's analyze. 8 a.m., round the clock, 8 to 8, that is already 12 hours, right? 8 a.m. to 8 p.m., that is already at 12 hours time use. Here, she traveled using a boat to Capri, 5 hours. She consumed 5 hours. So if you deduct 5, so the remaining time here is 7 hours, right? So our total journey time is the remaining 7 hours minus x. The remaining time here, so we already consume, right? There's a 5 hours and the remaining time is 7 hours. Okay, so how about time going back? So it means if we write it to our equation, we can say that the journey from Sorrento going back to Rome is 7 minus the time used in going. So that is x. Okay, so we are done with our time. We can go to our rate. Going 80 miles per hour and going back 60 miles per hour. So again, we apply our formula. Time times rate is equal to distance. Well, this will become 80x and this will become 60, the quantity of 7 minus x. Okay. Since our distance is the unknown, they are equal, right? This distance going back is equal. It does not change. Okay? So here, this is D1 and this is D2. The distance traveled going back, going to Sorrento, and the distance traveled does not change. It is constant. So we can say, to formulate our equation, that D1 is equal to our D2. Finally, if we write our equation, this is 80x minus 60 quantity 7 minus x. Okay, so we multiply 60 times 7, that is 420. This is 80x is equal to 420 minus 60x. So we transpose 60 to the other side. That will become 140. 140x is equal to 420. Therefore, our x is 420 over 140, or equal to 3. 3 hours. But wait, the unknown is how far is from Rome. How far is from Rome to Sorrento? So we substitute. It's either from the two. It's either from D1 or from D2. So if we substitute 80x or 80 times 3, so the distance, or D1, is equal to 240. So 240. What is the unit for our distance here? That is in miles. Let's check. Since our equation says that D1 is equal to D2, let's substitute the value of x to D2. So what is the value of our D2? That is 60 times the quantity 7 minus x. So if we substitute 60, 70 minus what is the value of our x? That is 3. That is 60. 4. Finally, our D2 is equal to 240. Again, unit, miles. So, if you can see, based on our equation, we have an equal answer of D1 and D2. So, we can say our answer is correct. That is the distance from Rome to Sorrento. That is 240 miles. Okay, moving on to our next example.